another worksheet. I'm really not looking forward to this test on limits and applications of derivatives this Monday.
Yo, hold it. Why do you have so many textbooks in your bag?
Dude, it's windy out today.
So? You gonna blow away?
Maybe.
Hold.
What are we working on? What?
That's my seat, dude.
Get out. Alright, you just want to be close to Jones.
What is these musical chairs? I need his help.
Alright, we have to get started on this worksheet. We have a test on Monday, guys.
Okay, what's the first problem?
Davis.
You forgot to read. Oh well, I'll read it. Okay. fx equals x to the third plus 6x squared minus 2. Find the max and min. What do we do first?
What's the max and the min?
Davis.
If you don't know anything, you literally don't know anything. I'm so good at this. I'm gonna get 100 on this.
Okay.
I just know it. Jones, how do you do this?
You know, guys, I think it's best that we go to one of our houses this weekend and we study.
Nah.
Alright, you know what? Sounds good. Sounds good.
And fathers, you might as well come too.
Yeah, you need me.
And Davis,
I'm
you
deaf
need to
going.
come. You're deaf going.
And we'll bring in these two.
We'll bring a silent Ryan and what's this in this case?
Yeah.
Alright, let's go.
Okay, yeah, I'm done.
Alright, boys. You ready?
Yeah.
Alright, so this test is going to be on limits, continuity, and discontinuity. So I think the major factor and the major point we need to know starting off is that if something is differentiable, it's also going to be continuous. Also, if the limit at a certain value, the limit as we approach a certain value doesn't necessarily have to equal the value at that point. So you see we have removable discontinuity. You can still take the limit from the left and the right, just f of that value is going to be a different. Yeah, Holden?
Is it true that if there's a sharp turn that it's not differentiable?
Yeah, I mean, if you look right here, there's a giant sharp turn, so it's not differentiable. So that's a major factor we needed to know for the test. But another point we should know is that if the limit of the first derivative from the left and the right is the same, that means it's differentiable, even if it's a piecewise function. So these are two separate curves, but the limit of the derivative of the left part and the right part is the same approaching this value, so it's going to be differentiable there. But here, that's not the case, so it's not going to be differentiable.
Wait, speaking of derivatives, can't you use the limit method to find a derivative?
You actually can. So let's say if we want to find the derivative of x squared, you would agree that that's 2x, right?
Yeah.
So I mean, if you want to use the limit method, you have to do this. Limit as delta x approaches 0 of f of delta x plus x minus f of x over delta x. Then if you plug in this for x, you get delta x plus x squared minus x squared over delta x, which ends up, when you factor that all out and do that all out, you end up with delta x x. You can factor out a delta x because you don't want to plug a 0 into the bottom because then it's undefined. So you end up with 2x plus delta x, the limit, as delta x approaches 0. So that's 0, so you end up with 2x, which is the same as that. You get that, Ryan?
Yeah.
Wait, what?
Ah, Davis.
When did you get here?
What about the roles and mean value thing?
Roles and mean value theorem. Those are also two important factors we should know about. Let me just fix up this graph here so I can explain them. So, I mean, let's start with the mean value theorem. I mean, you need, for the mean value theorem, it has to be continuous and it has to be differentiable. So let's say if we take this curve here, if we take this point there, and this beginning point, if we draw a secant from one to the other, mean value theorem says that at some value between this here and here, the instantaneous rate of change, or the slope of the curve at that point, the tangent at that point is going to be the same. So in order for that to be true, it has to be continuous and differentiable. And then Rolle's theorem says that if a point if we go from 2 points at the same value and it's continuous and differentiable, at some point in between them, as long as f of a is equal to f of b, at some point in between those 2 points, it's continuous, it's differentiable, f of the derivative's going to equal 0, which means there's going to be a minimum or a maximum. So that's what Rolle's theorem applies.
Wow, that was a lot of facts.
Yeah.
I'd say 7 of them.
7 facts indeed.
Wow.
We're halfway there.
You know, so since we've done limits, continuity, and differentiability, I think we should move along to applications of derivatives. So the first major application of derivatives is going to be when you come time for relative max and min. So you see you have a relative max and a relative, or like a relative min, and here you want to find the first derivative, find where it equals 0, and that's going to give you the relative max or min depending on the sign change about that point, and that's where it equals 0 is called a critical value.
Yeah, and f prime of x is dy over dx, or it's a change in y with respect to x, which means the first derivative is actually slope.
Yeah, the sign change of f prime of x, aka the first derivative, simply shows slope.
And the second derivative shows concavity.
Nice.
Yeah, no, that's right. And I mean, it's important to know what the derivative is compared to average rate of change to instantaneous rate of change. So derivative, first derivative at least, is instantaneous rate of change. And what that means is if you have this curve here, if you want to take from this point to this point, you could just draw a straight line, which is a secant, and that's average rate of change. But if you want to find the rate of change at a single point, the instantaneous rate of change, that's the derivative. So the tangent line at any point is going to have the slope of the instantaneous rate of change, the derivative, like that.
Yeah, and derivatives also play a big role in related rate problems.
What's a related rate?
Well, why don't I tell you? It's when the rates are related. Oh, you idiot! What?
That's not what a related rate is, Father. I mean, to some degree it is. What a related rate is, you see related rates a lot when it comes time for problems with volume. So let's take a cylinder. A related rate is when you have more than two variables. So you have to take into account different things. For example, the area of a cylinder is going to be pi r squared h. So here height is a variable, radius is a variable, and so is area. So you have to take into account those three different variables. It's not just y.
Wow, Trevor, you just taught us 14 good facts.
Whoa! Yeah, you guys ready for that math test tomorrow?
I'm pretty ready. I feel pretty confident.
No, I'm not ready.
Well. How about you?
What test?
We have a test tomorrow. David, what are we going to do with you?
Yo, hold it.
Hold it.
Hold it.
Andy?
You okay, buddy?
What happened? I got zoned out for a
What
second.
happened, man? Get back to work. I was doing really well in practice for this test. 12 out of 40. Again. You're a Faciner.